So we want to understand the crossings and genetics. The crossings. So mavala gas huko wanameki. So before we look at the crossings, there are some terms that we need to understand that will help us with the crossings. The first one is dominant. Dominant gene. Okay. Are you there? So when you hear the word dominant, it's a gene that expresses itself more than the other gene. So a gene that will express itself more than any other gene, it is called dominant. Okay, Manzaya. So this is a gene that expresses itself more than any other gene. Okay. A gene that expresses itself more than any other gene. It's called a dominant gene. Okay. So monohybrid in evidence. So yes, a dominant gene is one that expresses itself more than any other. Yeah, that is true. So now where is my cupboard? My cupboard is here. So if I was to give you, madam, a question of height, T and a small t, and then I ask you which one is a dominant gene between these two, what could be your answer? Very good. Why? Because you are seeing more of this gene to express itself. So madam, Marasangati Muribatari Bati. Why? Because of the bigger T is expressing itself more than the other one. So I'm a dominant gene ayo tumona. Mamonaka. They are the ones that we see. Kukashika, kutalimpa, those are dominant gene. We can't see akaka nonwak. So this one is dominant. So dominant genes are expressed with a capital letter. The other term is recessive. Recessive gene. So it's a gene that expresses less, a gene that expresses itself less than the other one. So nga mwamona kati ka small s, ka small n, ka small m, all those are recessive genes. They express themselves less compared to the other ones. Okay? So nga balanda shanshan recessive gene, they are talking about a small gene. Are you there? You've closed the gas. Then the other one is phenotype. Phenotype. Gamma phenotype, they are talking about the appearance of the gene. Is a person tall? Is a person short? Is a person light? Dark? Or brown? Whichever. Is a person sick of hemophilia? Is he Is he not sick of hemophilia? So that is phenotype. So phenotype, it's a color that you see. Say, Madam Mwarikashika, you know that. Mwarikashika, that is your phenotype. You get the idea. So that is my phenotype, color, appearance. You also have what is called genotype. Now, genotype, when you hear genotype, it's a combination of genes. Okay? It is a combination of genes. The genes or mumone, but genes that you can see in colors. I mean in symbols, sorry. So genotype, actual letters now to say, oh, the genotype oyo muntu yako oyo ni so. Mamonaka? Oyo muntu ni so. Oyo muntu ni black. But in at least nakwatako black brown. But the one that expresses itself in me is black. Brown, yali fisama, but it has expressed itself in my son. So genotype ma letters, in short. So these things will help us to understand how things will do work out under genetics. Okay? Awesome. So let's try to work out some examples and then see how these things will work out. But before examples, maybe 3 more definitions. Mendeleev. So we also have what is called codominance. Codominance. So codominance, madam, means when genes are expressing themselves equally. So codominance, when genes expresses themselves equally. Okay. So kulesa mukusango ati mwasa kwata ati BB mwasa kwata ati BB futi mwasa kwata ati I'm coming. Mwasa kwata futi ati BB namwimone isoga. These genes are of the same type, yeah? they are expressing themselves equally. If you get this one and this one, no one is more powerful than the other. Okay? As we go on, we are going to look at the blood groups also. Blood groups. So, blood group A and blood group B, these are called dominants. Tapabe abapo more powerful between A and B. There is no one which can express each other more than the other. So called dominance in our powers are the same when the genes are expressing themselves equally. Okay. Then qualibama terms like homozygous. Homozygous genes. It means same genes. Homozygous means same genes. Small letter, capital letter. Homozygous means what, madam? Same pair of genes. Yes. So if I have BB, this is homozygous. Small BB, that is homozygous. HH, not HH, haga in the higilema. No. HH for hemophilia. When I have small HH, that is homogeneous. Homo means same. Okay? Ngamwakwata B, small b, that's not homogeneous. It's not. Totally different. Why is it not the same? Because there's a capital letter here, there's a small letter. It's not homogeneous. Are you following? Which brings us to the last term, which is heterogeneous. Heterogeneous means different pair of genes. Different pair of genes. Hope you are writing those things. So different pair of genes means heterogeneous. If you've got H with a small h, this is heterogeneous. If you've got B with a small b, this is heterogeneous. S with a small s, that is heterogeneous. Gapari capital letter, small letter. Capital letter, small letter, that is heterogeneous. Okay? Heterogeneous. So let's look at an example. Let's look at an example and see how this can be done. So we have several examples, madam, before we. So I want you to say, in an experiment, in an experiment, a homogeneous top plant
Did what?
In an experiment, a homogeneous top plant was crossed with a homogeneous short plant. Okay. You are there? Question A, using a genetic diagram, draw a cross diagram you are there? Draw a cross diagram to show the phenotype of offsprings. Okay. That is question 1, which is question A. Question B, are you there on question B? Question A says, using a genetic diagram, draw a cross section to show the phenotype of offspring. They are there. Number 2, what is the chance or probability? What is the chance or probability? Are you there? What is the chance or probability of having an offspring? What is the chance or probability of having an offspring plant Are you there? An offspring plant. Number B1 there you say an offspring plant who is tall. Number 2, who is short. Number 3, who is a carrier of shortness. Okay. Who is the carrier of shortness? Okay. So let's go ahead and so there is a format how you do this diagram, and the format is the same. Okay. You start with parental, the word parental phenotype. Parental what? So when you say parental phenotype, kulanda ama-parents phenotype yabo, is it tall or short? So parental phenotype nabatwe bati, here you are dealing with a top plant. and a short, isn't it? A short plant, right? And then you now go to parental genotype. Parental genotype. Parental genotype. In space na impwiroko. Genotype ma genes in symbols. Okay? So tell me, madam, what are the genetic symbols for toe? Is it capital letter T, small letter t? What is it? Capital letter T, that's for toe. Okay? Short, it's small letter t. Because when you read the question, they said heterozygous. They said the homozygous. Question. You are following?
Yes.
After that, you now write the word garments. Just the crossing, it carries 5 marks. Garments, you separate this in 1. You also separate this. You separate T. You also separate T like that. You put them in circles as garments. Okay? Put them in circles as garments. Then now, move on. Since we have separated, this is T, another T, a small t, and another small t. Making the sun. So, you cross like this. So, follow. This is capital letter T, capital letter T. Then this one, you start from here, you come here. Naramba mwakulodeshen, madam. Watch on your screen there. They are saying ka round ka first circle kaenda na ka first circle. So T na small t. Mwaiona ka? Kamene aka kuenda pa next. Okay, I'm coming. Mwaona mwamene kaendera ka? Then mwenda kuli aka kayambamo bwera hapa kuvigumiza. T small t. Now ku T small t. So if evichtika, we call it RF, random fertilization. Like umwana uli onse kuti abo first, uli onse. Anything can come first, anything can come last. Yes. Iwe, tie. Balambo kufimba. Dalama mustama angi dawe na uja profesor kwa kitu mwachita tuje. So, so copy that. You are there? You've copied that? Which one? Yes, RF is just against these letters, random fertilization. RF, random fertilization. So, just below these things, we are going to write to say, we are going to write and say, just below those letters, first, but offsprings, bana manji, offsprings, okay? Offsprings will start with genotype. So you need to write offsprings genotype. So you need to write to say offsprings genotype. Vamene mwakrosinga ndiye vana vama plants ava. So vana ava, just a minute. What do I have? I can't see it. So genotype jambo listing tuma letters. Tuma letter twa first ni capital letter T with a small t, comma. Ka next capital letter T small t. Ka number 3 capital letter T small t. Capital letter T small t ndiye kaku last. That is genotype. The last thing you write is phenotype. Like vana. Phenotype ni kwamba okamba manji. Batali bali bangati, bafupi bali bangati. Batali bali bangati, madam. Yes, so you simply say auto. They are auto. Balipo mfupi hapa. Tima konga chili ku first. They are auto. Balipo mfupi hapa. They just have carriers. Balichena ma carriers ya tufupi. You get the idea, Kavena. Stereotype, so they are tall, but they've got they've got to ngono mukati. So this is that's all. Nishasira madam fully genetics diagram. You've gotten 5 out of 5 marks. So the question A has been answered. Let's go to question B. Let's go to question yes, B. They are looking for chance. Kuti, how many what? How many chance? Yes. So chance in probability, it's out of 100. So you say, Vana, we are saying they're out of 4. My plants, they're out of 4. So, valibangati vatari hapa. So you say 4, then vonse pamozi valibanga 4, isn't it? Times 100%. So meaning tikacha 4 into 4, 1. So meaning the chance is 100%. So there is 100% chance of having a top plant. Okay? Yes. If you want, you can just say 100% or 1. That is a chance. There is one chance. Number 2, a short one, right? Tell me, where are you seeing small t, like double small t? There is no. So you say 0 out of 4. If you divide, it will give you 0. So there is 0 chance of having a short plant. Number 3, carrier. Bali bangati macarrier pamaliapo. Bonse ni macarrier. Vigabenga. Bonse vili na matraits ya vikaolala. So you say, depa jamaa onati mufamily ati bonse sibambera. Bonse ni bakaolala. Why? They are all drunkards. So tizakwera menge hapo. Oh God. What's up, my people? Shile mwaneka lero zona. Ya. Chinzo chikaya. Eva prof bano. Ya. So, did you hear what I said? That don't you get surprised? Hey, kulichati family kaolala. Oluzibivela. Oro mama bisangwa para cha tate wake ni makariazi. Tamesha konko mfolo. So my carriers, they are 4 out of 4. So if you divide, the chance is 1. Okay? Now, the exercise I'm giving you right now is the exercise I'm giving you is I want you to rewrite the same question, but you should use the word we are going to have T with a small t. Then musebenzese na meke zani kaiti kweli. And then we have T with a small t. Sebenzese aya. So, and I want you to write the same questions for calculating. You will see that vizapezeka akovo chitika hapa mukrosinge mulembe ma genotype, phenotype, what parental and the like. Iwe letako. Yes, muzani uza mukasirizi. Yes. Napasa exercise.